we're going to solve a simple geometry problem, a sort of counting geometry problem, which is how many diagonals does a 100-sided polygon, a 100-gon, have? Here's what a segment of our 100-gon might look like. Remember that diagonals are segments that join the non-adjacent vertices of the 100-gon. Since it's a 100-gon, of course, it has 100 vertices. For example, these two vertices are adjacent. A side of the 100-gon connects them, whereas these two vertices are non-adjacent. So this segment joining them is a diagonal of the 100-gon. This is another example of a diagonal. Here's another diagonal. So again, the question is, how many diagonals are there in a 100-sided polygon? Again, I'm here by this empty cage of a 1900s animal sanctuary out here in the woods, but that's not why we're here. That's not interesting. We want to know how many diagonals are in this 100-sided polygon. There is a general solution to questions of this sort, but we're going to work out the solution from scratch. So give it a try yourself. My hint for you would be to count the diagonals sort of one vertex at a time. At each step, being careful to not double count the diagonals that you've already counted. Although we're going to solve the problem a slightly different way. So grab a cup of coffee and let's solve this problem.
Coffee Time Math with your host, Rav of Math.
Again, I'm unequipped with the coffee, just have the water, but that's going to have to do. The solution to this problem becomes quite clear when we just start to think about the 100 vertices of the 100-gon and the number of ways that segments could join them. So let's just answer that question. How many segments are there that we could create joining pairs of vertices if we have 100 vertices total? The answer, of course, is 100 choose 2, a binomial coefficient, because anytime we pick two vertices from 100, that defines a segment that joins those two vertices. Now, in fact, by definition, every one of those segments is a diagonal of our 100-gon, except for the 100 sides of the 100-gon. So to count up the diagonals, we simply have to count up all the segments, 100 choose 2, and then subtract the ones that aren't diagonals, which are just the sides, of which there are 100. So we subtract 100. That's our answer. Beautiful. But of course, it would be good form. We should simplify this a little bit to an expression that we can easily calculate. So doing that, 100 choose 2, that's going to be 100 factorial over 98 factorial times 2 factorial minus the 100. The 100 factorial and the 98 factorial will mostly cancel out. This is going to leave us with 100 times 99, and then in the denominator, we are just left with that 2 factorial, which is 2. And then again, we're subtracting the 100. Now, if we were to bring the 100 into this same fraction here, we would have to multiply it by 2 over 2. So it's like subtracting 2 times 100 over 2. Now, you can imagine what this would look like. We could just bring that minus 2 times 100 into this same numerator, and then we could factor a 100 out of both terms in the numerator. If we did that, we would get that this is equal to 100 times 99 minus 2, or 97, all over 2. So how many diagonals are there in a 100-sided polygon? The answer is 100 times 100 minus 3, all divided by 2. And this is suggestive of the general solution. If we want to reduce this to an actual number, the easiest way to do that in our heads would probably be 97 divided by 2, which is 48.5, multiplied by 100, which gives us our final answer, 4,850. That's the total number of diagonals in a 10-sided polygon. Again, as a matter of class, I'm going to forego the celebratory dancing, and that's it.
Subscribe for more of the swankiest math videos on the internet.